let us simulate this series RLC circuit in Simulink. First, in your MATLAB command prompt, type Simulink and hit enter. From these options that appear, go to Simscape and then select either electrical model or specialized power systems model. Let me select electrical model. A new window appears which contains a number of circuit equipments already and some help messages. Among these, I don't need this help message, so let me delete this. Let me delete this spectrum analyzer. I don't need it, and also I will delete this. Then let me zoom in, and here I shall draw the circuit diagram. To get the components like resistors, capacitors, inductors, click on library browser. Then from these options, search Simscape here. Then go to Foundation Library, under that electrical, and then under that electrical elements. From here, get a resistor and place it here. Then again go to library browser and take an inductor which is here. Then again take a capacitor and place it here. Then again go to library browser and go to electrical sources and take an AC voltage source and place it here. And then let us also take some voltage sensor and current sensor from the library browser. Under electrical sensors, here is a voltage sensor. Let me put it here. And again take a current sensor and let me keep it here. Okay, next let me set the value of this resistance by double clicking and typing the value, say 20 ohm. Then double click on the inductor and set the value to say 0.1 Henry. Then double click on the capacitor and set the value to say 300 microfarad. Okay. Then double click on the voltage source and set the amplitude of the source to be 100 volt and frequency 50 Hertz. Then let us join these components and build our circuit. For that, let me just click on this end of the resistor, drag and join with this end of the inductor. In the same way, click here, drag and join the inductor with the capacitor. In the same way, let me join this end of the source by clicking, dragging and joining with the resistor. Then let me join this end with this end of the source. Then before I can simulate this circuit, I have to set any one point in this circuit to have ground potential or zero potential, without which the simulation will not run. For that, here you see I have this symbol of ground terminal, which was automatically given to me when I started this simulation. So let me bring it close to here, and then let me join the lower point of the voltage source with this ground point. For that, let me right click here, drag and connect. Okay. Next, if I want to measure, say, the voltage, suppose across this source, then I will connect this voltage sensor with this source. For that, let me connect this positive terminal with this end of the source and this negative terminal of the sensor with this end of the source. Now this voltage sensor will measure the voltage, instantaneous voltage across this source. However, to get the output or display, I have to connect this, connect the output of this voltage sensor with an oscilloscope or scope. You see that here an oscilloscope is there, which was given to me automatically when I started this simulation. Let me bring this oscilloscope here. Let me rotate it. And then let me connect this output of the voltage sensor with the oscilloscope input. Okay, in the same way, suppose I also want to measure the current through this series RLC circuit. Okay, so for that I have to insert a current sensor in series with this RL and C. So let me first make some space by moving it towards the right. Then let me disconnect this wire and bring this current sensor here in between, and then let me join this current sensor in series. So plus terminal I join here and minus terminal I join here. Again, this current sensor can now measure the instantaneous value of the current that goes through this R, L or C. But to get the display or the waveform, I have to connect one oscilloscope with this current sensor. So let me just copy this oscilloscope and paste it here, and then let me connect the output of the current sensor with the oscilloscope. Now my circuit is ready to run, and I will first select the duration of simulation. Suppose I select 0.1 second duration, and then I will click on this run button. The circuit is working. Now to see what is happening, let me double click on this oscilloscope. A new window appears which shows the waveform of the voltage measured by this voltage sensor, that is the voltage across this voltage source. It is a sine curve with plus minus 100 volt amplitude. Let me close this and click on this oscilloscope, double click, and then another window appears showing the current waveform through this R, L and C. That is the current through this current sensor. Okay, this you can see it is a sinusoid with amplitude around 3.5 ampere.